is a massive, luminous pair of plasma held together by its own gravity. Our nearest star is the Sun, which is the source of most of the energy on Earth. Some other stars are visible from Earth during the night when they are not obscured by clouds or other atmospheric phenomena, appearing as a multitude of fixed luminous points due to their immense distance. Historically, the most prominent stars were grouped into constellations and asterisms, and the brightest star gained the proper names. Extensive catalogs of stars have been assembled by astronomers which provide standardized star designations. For at least a portion of its life, a star shines due to thermonuclear fusions of hydrogen into helium in its core, releasing energy that traverses the star's interior and then radiates into outer space. Once the hydrogen in the core of a star is nearly exhausted, almost all naturally occurring elements heavier than medium are created by stellar nuclear scientists during the star's lifetime, and for some stars by supernova nuclear scientists when it explodes. Near the end of its life, a star can also contain degenerate matter.
Astronomers can determine mass, age, metallicity, or chemical composition, and many other properties of a star by observing its motion across space, luminosity, and spectrum respectively. The total mass of a star is the principal determinant of its evolution and eventual fate. Other characteristics of stars including diameter and temperature, change over its life, while the star's environment affects its rotation and movement. A plot of the temperature of many stars gain their luminosity is known as a Hertzsprung and Nusselt diagram or HR diagram. Whilst the age and evolutionary state of a star to be determined, a star's life begins with the gravitational collapse of gases, nebula of neutron compost, primarily of hydrogen, along with helium and trace amount of heavier element. Once the stellar core is sufficiently dense, hydrogen becomes steadily converted into helium through nuclear fusion, releasing energy in the process.
Of the star's interior carries energy away from the core through a combination of radiative and convective process. The star's internal pressure prevents it from collapsing further under its own gravity. Once the hydrogen pole at the core is exhausted, a star with at least 0.4 times the mass of the Sun expands to become a red giant. In some cases, fusing heavier elements at the core or in shells around the core. The star then evolves into a degenerate form, recycling a portion of its matter into the interstellar environment, where it will form a new generation of stars with a higher proportion of heavy elements. Meanwhile, the core becomes a stellar remnant, a white dwarf, a neutron star, or if it's sufficiently massive, a black hole.
And multi-star system consists of two or more stars that are gravitationally bound and generally move around each other in stable orbits. When two such stars have a relatively close orbit, their gravitational interaction can have a significant impact on their evolution. Stars can form parts of a much larger gravitationally bound structure, such as a star cluster or a galaxy. As you may or may not know, stars actually come in a variety of colors. But do you know all of the different colors that stars can be? In this video, we will explore why stars come in different colors, and then we will identify all of the different colors that stars can be.
A star appearance depends mainly on the temperature that it burns at. More specifically, the color is directly related to the surface temperature of a star. In the lowest temperature range, stars appear in the red color family. At the highest temperature, stars appear blue. In general, stars are categorized by certain types depending on their temperature, and those temperature range and types are as follows.
Some stars are yellow, some are blue, some are red and some are white. The color of each star, it's true, depends upon its Fahrenheit. The color of a star, you can be sure, is mostly